Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about statics exercise 8.1 and 2, example 4 and 6. So student, let's go look at the board. Student, example 4. Resultant of forces P and Q acting at a point trisects the angle between them. Show that the angle between them is 3 cos inverse P by 2Q and the magnitude of the resultant is P square minus Q square by Q where P greater than Q. So student, attention please, look at the board. Now let OA let OA BC is a parallelogram and let P and Q be two forces acting at a point O along OA and OB respectively, and let angle between two forces is 3 alpha and their resultant force are acting at a point O along OC, which makes an angle with OA is alpha because acting at a trisect the angle between them. So I say again student, let P and Q be two forces acting at a point O along OA and OB respectively. Angle between two forces is thrice alpha and the resultant force are acting at a point O along OC, which makes an angle with OA is alpha. It is according to conditions. Now student, here angle AOB equals to thrice alpha and angle AOC equals to alpha from figure. So student, we have here angle BOC equals to 3 alpha minus alpha is twice alpha. Student, attention please, here AOC is alpha, so BOC is twice alpha. So we have BOC equals to ACO, it is alternate angle, it is twice alpha. So angle ACO equals to angle BOC equals to twice alpha. So student, I hope that you are clear. This is twice alpha and this is twice alpha because alternate angle. And angle OAC equals to 180 degree minus alpha minus 2 alpha minus twice alpha. So 180 degree minus thrice alpha. So angle OAC equals to 180 degree minus thrice alpha. Student, we know that in triangle AOC sum of three angle equals to 180 degree. So angle A equals to 180 degree minus thrice alpha because alpha plus twice alpha equals to 3 alpha. So angle OAC equals to 180 degree minus 3 alpha because we know that sum of three angle equals to 180 degree. Sum of three angle in triangle equals to 180 degree. So student, attention please, here angle triangle AOC, here AOC is alpha, ACO is twice alpha and OAC equals to 180 degree minus 3 alpha. And here force Q acting at a point along OB, here OB and AC are parallel to each other. So here OB equals to AC equals to Q. So in triangle AOC, in triangle AOC, by sine rules of forces, by sine rules of forces, you have learned, students, sine rules of forces here in triangle AOC. So here force P by sine opposite angle is twice alpha. So P by sine twice alpha equals to Q by sine, Q, force Q, so opposite angles alpha, so sine alpha, and force R by sine opposite angle is 180 degree minus 3 alpha. You have learned, student, you have learned sine rules of forces, P by sine 2 alpha, Q by sine alpha, and R by sine 180 degree minus thrice alpha. Then next line, P by sine 2 alpha equals to Q by sine alpha equals to R by sine thrice alpha. And here, student, you have learned 180 degree means 90 into 2. 2 is even multiple. So even multiple, sine, same sign, trigonometric function is same. So sine and theta is thrice alpha. And second quadrant always sine positive. So sine 180 degree minus 3 alpha equals to sine 3 alpha. So student, by sine rules of forces, P by sine 2 alpha, Q by sine alpha, and R by sine thrice alpha. Here we can write P by sine 2 alpha equals to Q by sine alpha. Now we get P by we don't have sine using formula. We don't have sine 2a, sine 2 alpha equals to 2 sine into cos a using trigonometric formula. 2 sine alpha into cos alpha equals to Q by sine alpha. Now eliminating both sides by sine alpha. So sine alpha cancel, then we get P by 2 cos alpha equals to Q by 1. By cross multiplication, 2Q cos alpha equals to P. By cross multiplication, 2Q cos alpha equals to P, or cos alpha equals to P by 2Q. So student, here alpha equals to cos inverse P by 2Q. So here angle between two forces is thrice alpha. Now we get alpha equals to cos inverse P by 2Q. So multiplying both sides by 3. So 3 alpha equals to cos inverse 3 cos inverse P by 2Q. So student, record angle between two forces. So record angle between two forces is 3 cos alpha 3 cos inverse P by 2Q. So student, here angle between two forces is 3 alpha. So we have record angle between two forces 3 cos inverse P by 2Q. Proved. I hope that student you are clear. Student, second condition, show that the resultant magnitude of the resultant is P square minus Q square by Q, P greater than Q. Now from equation we have second part is Q by sine alpha, then we can write Q by sine alpha equals to R by sine 3 alpha. Then find the value of resultant force R, magnitude of the resultant force R. So we have Q by sine alpha equals to R by, student, here using trigonometric formula, you have learned, student, trigonometric formula sine 3 alpha equals to 3 sine alpha minus 4 sine cube alpha. So using this formula, 3 sine alpha minus 4 sine cube alpha, student, then here using trigonometric formula sine 3 alpha equals to 3 sine alpha minus 4 sine cube alpha. Now we have dividing both sides by sine alpha, eliminating both sides by sine alpha. So we can write q by 1 equals to r by 3 minus 4 sine square alpha, and then we have q by 1 equals to r by 3 minus 4, and then using formula sine square alpha, student, we know that sine square alpha equals to 1 minus cos square alpha. This is trigonometric formula. So using formula, we know that sine square alpha equals to 1 minus cos square alpha, and then q by 1 equals to r by 3 minus 4, 4 into 1 is 4, minus minus will be plus 4 cos square alpha. So next line, student, here, or q by 1 equals to r by 3 minus 4 equals to minus 1 plus 4 cos square alpha, minus 1 plus 4 cos square alpha. Now cross multiplication we get. So r equals to q into minus 1 plus 4 cos square alpha. So student, here r equals to minus q plus 4 q cos square alpha. So student, here cos alpha equals to p by 2q, cos alpha equals to p by 2q from first conditions. Now putting the value of cos alpha equals to p by 2q, so minus q plus 4q into cos alpha equals to p by 2q, then whole square. Student, I say again, cos alpha equals to p by 2q from first conditions, we have cos alpha equals to p by 2q. Now putting the value of cos alpha equals to p by 2q, then simplify, or r equals to minus q plus 4q into p square by 2q square, 2q or 4q square, 2 square means 4q square, 4 cancel, q cancel. Now we get r equals to minus q plus p square by q. Then LCM, here LCM is q minus q square plus p square. So resultant magnitude of the resultant force is p square minus q square by q when p greater than q. So student, we have required magnitude of the resultant force is p square minus q square by q when p greater than q. This is proved. I hope that student, you are clear. Student, example 6, it's very important question for your examination. So student, attention please. Example 6, resultant of forces p and q acting at a point is r, and if the resolved parts of the force r along the direction of force p is q, then show that angle between the forces is alpha equals to 2 sine inverse alpha equals to 2 sine inverse root over p by 2q equals to cos inverse q minus p by q, and resultant force r equals to root over q square minus p square plus 2pq. So student, attention please, look at the board. Now here let let P and Q be two forces acting at a point O along OA and OB respectively, and angle between two forces is alpha. Angle between two forces is alpha, and the resultant force R acting at a point O along OC, which makes an angle with OA is theta. So I say again, student, here P and Q be two forces acting at a point O along OA and OB respectively. Angle between two forces is alpha, and the resultant force are acting at a point O along OC, which makes an angle with OA is theta. So student, according to question, taking the resolved part of R, resolved part of force R along P or OA. So taking resolved parts of force R along P or OA equals to R cos theta. You have learned, student, taking the resolved part of force R along P or OA is R cos theta, because R makes an angle with OA is theta. So resolved part of force R is R cos theta. According to question, R cos theta equals to Q, equation number 1. This is according to question. Resolved part of force R along the direction of force P is Q. So R cos theta is equals to Q, because R makes an angle with P is theta. So resolved part of R along OA or P is R cos theta. So R cos theta equals to Q. Again taking the resolved parts of the forces we get. So student, here resolved part of P, we know that resolved part of P is P cos 0, because along OA, resolved part of forces along OA or P. So we have P cos 0 plus resolved part of Q is Q cos alpha, because angle between two forces is alpha. Q makes an angle with OA is alpha. So student, attention please, you have learned resolved part. So resolved part of P is P cos 0, because along OA. So P cos 0 plus Q cos alpha equals to the resultant force. Resolved part of resultant force is R cos theta. Resolved part of resultant force R cos theta, because R makes an angle with OA is theta. So resolved part of R is R cos theta. So student, by using resolved part formula, resolved part of P plus resolved part of Q equals to resolved part of the resultant force R. So R cos theta. Now student, here cos 0 means 1 plus Q cos alpha equals to, putting the value of R cos theta from equation 1, and R cos theta equals to Q. So putting the value of R cos theta equals to Q from equation 1. Now student, here P equals to, then take it to the right side of Q cos alpha. So Q minus Q cos alpha, or P equals to, now taking common q from right hand side, then we get 1 minus cos alpha. So p equals to q into 1 minus cos. So we have interchanging left and right. So q into 1 minus cos alpha equals to p, or 1 minus cos alpha equals to p by q. Take it to the right side of q. So student, from the formula, then we can write here 1 minus cos 2 into alpha by 2, taking 2 and divide 2, because from the formula 1 minus cos 2a, here a is alpha by 2 and right side p by q, right side is p by q. Now student, here using formula, trigonometric formula 1 minus cos 2a, you have learned student a trigonometric formula 1 minus cos 2 alpha equals to 2 sin square alpha. Here alpha is alpha by 2. So using trigonometric formula 2 sin square alpha means alpha by 2 equals to p by q. Here using formula 1 minus cos 2a equals to 2 sin square a. Now take it to the right side of 2. So sin square alpha by 2 equals to p by 2q, or sin alpha by 2 equals to root over p by 2q, or alpha by 2 equals to sin inverse root over p by 2q. So angle between two forces equals to 2 sin inverse root over p by 2q. So student, angle between two forces is 2 sin inverse root over p by 2q. So angle between two forces is alpha equals to 2 sin inverse p by 2q. Again p plus q cos alpha equals to q. From you taking resolve part of forces along OA or P. So P plus Q cos alpha equals to Q. Now student, here Q cos alpha equals to, take it to the right side of P. So Q minus P, or cos alpha equals to Q minus P by Q, equation number 3. Equation number 3. So alpha equals to cos inverse Q minus P by Q. So student, here given here from we have P plus Q cos alpha equals to Q, and Q cos alpha equals to Q minus P. Take it to the right side of P. So cos alpha equals to Q minus P by Q, and alpha equals to cos inverse Q minus P by Q, equation number 4. Now from equation 2 and 4 we get, from equation 2 and 4 we get, so alpha equals to 2 sin inverse root over P by 2Q equals to cos inverse Q minus P by 2Q. So student has proved. I hope that student you are clear. Now student, find the resultant magnitude of resultant force R. So by the parallelogram law of forces, we know that parallelogram law of forces, R equals to root over, we know that R equals to root over resultant force, R equals to root over P square plus Q square plus 2PQ cos alpha. We know that student resultant force R equals to root over P square plus Q square plus 2PQ cos alpha. Now putting the value of cos alpha from equation 3, we get cos alpha equals to q minus p by q. So student, putting the value of cos alpha equals to q minus p by q. So here root over p square plus q square plus 2pq, and putting the value of cos alpha is q minus p by q. From equation 3 we have cos alpha equals to q minus p by q. Now next line, p square plus q square and q cancel, so 2p into q minus p. So next line, p square plus q square plus 2p into q means 2pq, and 2p into p is minus 2p square. So student, here root over q square minus 2p square plus p square, minus 2p square plus p square is minus p square plus 2pq. So magnitude of a resultant force R equals to q square minus p square plus 2pq, hence proved. I hope that student you are clear. So student, it's very important question for your examination. See you again next class. Allah Hafiz.